Section 6.3 is we're going to go over some properties of trig functions that may have become obvious to you in section 6.2, but I'm going to explicitly state them now. What we've done in this section is we've now replaced t, the t that we were so ambiguous about, with theta, which is what it's equal to. And we're still looking at a unit circle here. We can tell we're looking at a unit circle because this point on the outside edge of the circle goes out to 1. If you look at this original function, all that we've done here is we've replaced the t in that function with the theta, which I was using already, so we're good to go here. If you look at the value of sine, in this section we're going to be looking at the domain and the range of the trig functions. Sine is a value of y. First of all, we input an angle. This angle can be anything you want it to be for sine. And you're going to get out a value of y. Y here oscillates between 1 and -1. What that means is the range of sine oscillates between 1 and -1. Likewise, the range of cosine will oscillate between 1 and -1 because x is what cosine theta is equal to. We can put any angle we want into there. That's why the domain here is all real numbers. The range, though, for sine and cosine is going to oscillate between 1 and -1 because when you go around a circle, a unit circle, that's all you get. Tangent, if we look at this is going to be y over x. So the domain of the function for tangent has to be such that x is not equal to 0. Well, x is equal to 0 right here at these y-axes. And if we remember the value of the angles in radians, this is going to be pi over 2 and 3 pi over 2. So it looks like it's going to be at odd integer multiples of pi over 2. 1 pi over 2, 3 pi over 2. Not 4 pi over 2. It's just 1, 3, 5, 7, 9, 11, so forth and so on. Because if we have 2 pi over 2, that's pi. So that's why it has to be odd integer multiples of pi over 2. Now, tangent can be any number you want it to be, because if I look at the ratio of any number between -1 and 1 divided by any number between -1 and 1, I get a whole bunch of different numbers. And you can look at the graph of tangent x and see that it's going to go off to infinity and negative infinity. Cosecant will be odd because cosecant can be any value of y such that y is not equal to 0. Well, y is equal to 0 on the positive x-axis. So cosecant can't be multiples of pi. So 0 pi, 1 pi, 2 pi, 3 pi, or 180 degrees. So this is going to be, the range, though, is going to be all real numbers for cosecant that are bigger than 1 or less than -1, because 1 divided by a number smaller than 1 is going to give you a number bigger than 1. And you can go through the same process for all of these. You have restrictions on the domain for all of the tangent, cotangent, secant, and cosecant functions. For sine and cosine, though, the domain is all real numbers, because there's no way to make this denominator 0. These are undefined if the denominator is 0. So that's how you tell the domain. Range, sine, and cosine are going to oscillate between 1 and -1. Secant and cosecant, they're going to be bigger than 1 or less than -1. Tangent and cotangent, the range will be all real numbers. When we talk about the period of a trig function, we're talking about the time it takes to go around until we get the same exact value back. And it's going to be multiples of 2 pi. So we would say then that the period for sine and cosine is going to be 2 pi. For sine, cosine, cosecant, and secant, we say that the period, the time it takes to go through one complete cycle, is 2 pi. But for tangent and cotangent, the period is going to be pi. And you can see these on the periodic properties, sine, cosecant, cosine, and secant. We get 2 pi, but for tangent and cotangent, the period is pi, because remember, tangent and cotangent are x over y and y over x. In quadrant 1, you get the same sine functions. In quadrant 3, you get the equal values. So the period here for tangent and cotangent is going to be pi. This is the only one that's different. This period is pi. All of the other periods are 2 pi. That's the time it takes to go through, or the measure of angle it takes to go through one complete cycle. We can find the exact value of the trig functions by using the periods here. 17 pi over 4. What is 17 divided by 4? Somebody have a calculator? It's 4 and what? 4 and 1/4? I can say that this is going to be pi over 4 plus 4 pi. Well, this just means I'm going around the unit circle 2 times. So sine 17 pi over 4 then is going to be equivalent to sine of pi over 4. And sine of pi over 4 is, think back to your little table that you did, the square root of 2 over 2. Okay, it's 45 degrees. Don't translate the radians to degrees, though. Remember, we put an angle in, we get a numerical value out, and it's going to take some practice to get comfortable with that. Cosine of 5 pi. Well, 5 pi is equivalent to 1 plus 4 pi, right? And 4 pi is a multiple of 2 pi, so that just tells us how many times we're going around the circle. So that means then that this cosine of 5 pi is going to be equivalent to cosine of what? 1 pi, and cosine pi is negative 1. Think about the unit circle. Cosine is the x value. This point, the coordinates for this point are negative 1, 0. Cosine is the x value. The way you can keep this straight is the ordered pairs go in alphabetical order. We do that to keep the English people off our backs. Ordered pairs are x, y. That's in alphabetical order. X goes with cosine. Y goes with sine. Those are in alphabetical order as well. That'll help you keep it straight. Tangent of 5 pi over 4. Now, tangent has a period of pi. 5/4 is equal to 1 and 1/4. 4/4 plus 1/4 is 5/4. 4/4 is 1. This means then that this will be equivalent to, because the period is pi, we have 1 pi, this is going to be equivalent to tangent of what? Pi over 4, and tangent of pi over 4 is 1, because the value of sine and cosine are the same. The period here is 2 pi. So what this means is if I have an angle and I'm adding multiples of 2 pi to it, then sine of that angle plus multiples of 2 pi is just going to be sine of the angle. So what I did was I took this angle that's in radians and I figured out what it would be as adding the two angles together, so that I ended up with a multiple of 2 pi. 4 is a multiple of 2 pi. By the periodic properties, sine of pi over 4 plus 2 times 2 pi, that's just telling me I go around the circle 2 times, is going to be the same as sine of pi over 4. So what I did was I went to the calculator. I'm not explaining myself well. Let me try again. Sine of 17 pi over 4 is the same as sine of pi over 4 plus 4 pi. I'm just breaking the 17/4 down into fractions. And I used the calculator to help me with the fractions. I said 17 divided by 4 is 4 1/4, right? So I said, well, 4 1/4 is going to be 4 pi's, because we're looking at multiples of pi. This is why I said I like radians. We can deal with the fractions and then just stick the pi on at the end. So this is 4 1/4, right? If you don't know what the fraction part is, take that, subtract off the whole part, and you're left with the decimal. Change that to a fraction by hitting math enter, and that gives me the 4 1/4. We said then that the 1/4 plus the 4 is going to be the same thing as sine of pi over 4 plus 4 pi. But 4 pi is going to be coterm, because this is an addition of two revolutions around the circle. Sine of 17 pi over 4 is coterminal to sine of pi over 4. That's where I went from the blue to the purple. From blue to purple, what I mean is from here to here, these are going to be coterminal. I go around the circle, starting out. There's 2 pi, 3 pi, 4 pi, and now I go out 1/4, and that's going to put me right here. And this angle is coterminal to pi over 4. So the angle that goes around 2 revolutions, which is what 4 pi radians is 2 revolutions, is going to stop if my angle is 17 pi over 4, it's going to stop here at pi over 4. So that's why I said sine of 17 pi over 4 is equivalent to sine of pi over 4, and sine of pi over 4 is square root of 2 over 2. Let me make one up, just to see if we've really got it. So we're going to call this one part B. What if I have cosecant 19 pi over 6? Well, on my calculator, what I would do is I would take 19 and I would divide it by 6. And I get 3.1667. Well, I want to know what that decimal part is as a fraction. So I'm looking at minus 3, the whole number, and I'm going to change that part to a fraction. So that's 1/6. So this is going to be equivalent to cosecant of, that was 1/6. I needed to take away 2 pi. Pi over 6 plus pi plus 2 pi, because that takes care of the 3 pi. Multiples of 2 pi are going to be terminal angles. So this is going to be equivalent to cosecant of pi over 6 plus 6 pi over 6. That's going to be 7 pi over 6. Because pi over 6 plus pi is 7 pi over 6. Pi over 6 plus pi is 7 pi over 6. See, I can only take away the 2 pi, the multiples of 2 pi, because the period of cosecant is 2 pi. Cosecant, you've got an angle, you add 2 pi to it, it's going to be cosecant of that angle. 7 pi over 6, if you draw your quadrants here, you're going to go around one complete revolution, that's 2 pi. And then we need another pi. Well, that's going to put us over here at the negative x-axis. And then we add 1/6 to that, and that's going to put us right here where this angle, the reference angle right here, is pi over 6. Cosecant is the reciprocal of what trig function? Sine. And sine of pi over 6 is 1/2. Thinking back to your table that we did. So cosecant 19 pi over 6 is going to be equivalent to 1 over sine of pi over 6, but it's in quadrant 3, so it's going to be negative. So this is going to be equivalent to negative 2, because the reciprocal of 1/2 is 2. Negative because it's in quadrant 3, and sine and cosecant are negative in quadrant 3. Tangent and cotangent are positive in quadrant 3. I'm tying everything together that we just went over. I mean, everything. Reference angles, trig, sines. And here's the fancy chart I was talking about. All students take calculus. So I was just one section ahead. So maybe now we can practice some more. If sine is greater than 0 means positive, and cosine is negative. Name the quadrant in which the angle theta lies. Quadrant 2. That's the quadrant where sine would be positive and cosine negative. It cannot be any other one. But what if I said the quadrant where cosecant is positive and secant is positive? That would have to be quadrant 1, because they're all positive there. What if I said the quadrant where tangent is positive and cotangent is positive? What would be our choices there? 1 or 3, because that works either way, so we couldn't narrow it down to just one quadrant. We don't have enough information. Well, we just don't have enough information to narrow it down, so consequently probably would not be given just this information. I just wanted to test your understanding of quadrants and sines. Here's some identities. These are fundamental identities. These are called ratio identities here. Tangent of theta is the ratio of sine over cosine. These are called reciprocal identities because cosecant is the reciprocal of sine. Sine is the reciprocal of cosecant. Vice versa. It goes both ways. And then these last ones down here are called Pythagorean identities. Sine is y, cosine is x. X squared plus y squared equals 1 from the unit circle. But because they're dealing with squares and hypotenuses, if you drew a right triangle, they're called Pythagorean identities. These need to be committed to memory. We can use these identities now to find the exact values when sine and cosine are given for any of the trig functions. So here we're told sine theta is equal to the square root of 10 over 10. Cosine of theta is equal to the cube root of 10 over 10. Find the value for each of the 4 remaining trig functions. We're going to find the value for tangent and cotangent, secant and cosecant. So tangent is sine over cosine, 3 square roots of 10 over 10. So now the 10s are going to cancel out because they're the same and they're in the denominator. The square roots of 10 are going to cancel out because they're both in the numerator. And this is going to simplify to 1/3. So what is cotangent theta? 3. That's nice. Secant is 1 over cosine. So that's going to be the reciprocal of this, which is going to be 10 over 3 square roots of 10. And if you were to rationalize this denominator, we would end up with square root of 10 over 3. Cosecant is the reciprocal of this, which is going to be 10 over the square root of 10. And if you rationalize this, you're just going to get the square root of 10. Do you need to see that step, how I rationalized it? So I have 10 over 3 square roots of 10 times the square root of 10 over the square root of 10. And that's going to give me 10 square roots of 10 over 3 times 10, and then the 10s are going to cancel out here, and that's where this came from. Finding the exact value of a trig function using identities. Alright, because we see squares here, I'm thinking I probably want to use a Pythagorean identity. We have sine squared plus cosine squared equals 1. Well, 1 over cosecant is sine. So this would be equivalent to sine squared 35 degrees plus cosine squared 35 degrees. And by the Pythagorean identity, that is equal to 1. Alright, this is cosine pi over 3 divided by sine pi over 3. Cosine divided by sine is cotangent pi over 3 minus cotangent of pi over 3, and that is equal to 0, using the identities to help you. Finding exact values of trig functions of an angle given one of the functions and the quadrant of the angle. There are multiple ways to go about doing this. I'm just going to pick one and go with it, and if you know another way that makes sense to you, feel free to share. So we have sine theta is equal to 2/5, and cosine is negative. That means that theta terminates in what quadrant? Quadrant 2. This point right here is going to be 2. This is our angle theta, and that means that the x value here, if I were to drop a perpendicular, would be negative. This distance right here is 2, the x value is negative, and the r is 5. Personally, I like right triangle trigonometry better. This is going to be 2, this is going to be 5. Using the Pythagorean theorem, we get x squared plus 2 squared equals 5 squared. That means that this is going to be the square root of 21, if you set that up and solve it, for the missing side. It's going to be the square of the hypotenuse minus this squared, and then take the square root of the whole thing. 25 minus 4 is 21, take the square root of it. So what that means is x here then is equal to the negative square root of 21. Find the remaining 5 trig functions. We have sine. What is cosine theta going to be? I don't know theta, and that's okay. Cosine theta is negative in quadrant 2, is it not? So cosine theta is going to be negative adjacent over hypotenuse. Cosecant theta is going to be positive or negative? Positive, because it's the reciprocal of sine. So the reciprocal of 2/5 is 5/2. Tangent theta is opposite over adjacent. Remember, this is a negative square root of 21 here. So that's going to be a negative 2 over the square root of 21. But that'll rationalize into negative 2 square roots of 21 over 21. Cotangent is negative 21, square root of 21 over 2. And what am I missing? Secant. Secant theta, is that going to be positive or negative? Secant is the reciprocal of cosine, so that's going to be negative 5 over the square root of 21. But when you rationalize that, there you go. The question was, how did I get the square root of 21? I'm using the fact that x squared plus y squared is equal to r squared. X, I don't know. Y is 2. R is 5. So there's two methods of finding the values of trig functions of theta when the value of one function is known and the quadrant is known. What I've done is I've combined using method 1 with method 2. Method 1 is drawing a unit circle, but I only drew the triangle part of the unit circle and used the fact that we have the Pythagorean theorem here, or the equation of a circle, x squared plus y squared equals r squared, so we can find r. And then I used the identities, the reciprocal identity, the ratio identity, and all of the unit circle stuff, and I blended the two methods. We can do it again. Here we're told cotangent is 1/3 and sine is negative. So what quadrant does theta terminate in? Theta is in quadrant 3. If cotangent is positive and sine is negative, that means that our angle has to be in quadrant 3. And cotangent's x over y. So x is 1, y is 3, and that puts our angle right here. So there's your angle, theta. Both x and y are negative. Is tangent going to be positive or negative? And before I do anything, do I know what tangent is? If I know cotangent, do I know tangent? It's the reciprocal. Is sine going to be positive or negative? Cosine, positive or negative? Cosecant and secant. Notice I take care of the signs of the trig functions first, the positives and negatives, and I know that because this is quadrant 3. Only tangent and cotangent. All students take calculus. Tangent and cotangent are positive. I know a value for x. I know a value for y. I only need to find r. How do I find r? R is equal to the square root of x squared plus y squared. That comes from the equation of the unit circle, x squared plus y squared equals r squared. Solve that for r and you get this. So this is going to be the square root of, tangent is going to be y over r. So this is going to be negative 3 over the square root of 10. But negative 3 over the square root of 10 can be rationalized to what? Negative 3 square roots of 10 over 10. If I know sine, I also know cosecant. What is cosecant? Square root of 10 over 3. Can I figure out cosine? Negative square root of 10 over 10. And secant is negative square root of 10. To go from here to here, I just rationalize the denominator. Multiply the top and the bottom by the radical that's in the denominator. It's easier to tell from this function with the radical in the denominator what the reciprocal is going to be. So that's why I left that there. And I left that there instead of just going with this. And then the last thing we're going to look at here is using even and odd properties to find exact values of trig functions. Remember back from college algebra, and we're digging way back into the even and odd stuff. And odd functions, what you get whenever you replace the x with a negative x and you get the opposite function back. So sine, cosecant, tangent, and cotangent are all odd functions. Here, if you replace the theta with a negative theta, you get the same function back. These are even, and it's easier to just label the even functions and know the others are odd. Because cosine and secant are even functions, cosine of negative 60 is going to be the same as cosine of 60, and cosine of 60 is 1/2. Look at your table if you need to. You can recreate that table for your exact values of your special angles on your test so that it's in front of you. Sine of negative 390 degrees is going to be the opposite of sine 390 degrees. But 390 degrees is bigger than 360, is it not? So this is going to be negative sine of, what's my coterminal angle? 30 degrees, because 390 minus 360 is 30. So this is going to be negative 1/2. Tangent. Tangent is an odd function, so this is going to be the same as negative tangent 37 pi over 4. Go to our calculator. What's 37 divided by 4? 9 1/4. And what is the period of tangent? Pi. So at every multiple of pi it repeats. So this is going to be equivalent to negative tangent 1/4. 0.25 is 1/4. And this is going to be negative 1. I'm using our special angles. I'm using reference angles. I'm using signs of trig functions and evens and odds. I'm tying all of these little individual rules together And that wraps up section 6.3.